Thank you. Great news. Awesome. Thank you very much. Do you want those too, or do you want to save those? Okay. One back that one, or the top two. Okay. All right. So that I can get the point across to the people on the video. Okay, exact values on the test. When we talk about exact values, we are talking about chart stuff. So square root of 3 over 2, square root of 3 over 3, things like that. Okay, this is exact values. When you're asked for that, it is not calculator. In fact, most of this test is not calculator based. And most of this test is going to be based on the chart, and things like that. As we're about to talk about, there will be some questions that will be that will be calculator based. The majority is going to be chart stuff. And when you see exact values, that absolutely means chart stuff, no calculators. The formulas that are listed here you'll be given are the ones from 6.6. So S equals R theta, omega equals theta over T, V equals S over T, and A equals 1/2 R squared theta. I think those are all right, but those are the 4 formulas you'll be given. Okay? Right now we're doing the tangent of 5 pi over 6. Talk to me about tangent of 5 pi over 6. What's the first step? I am not yet fluent in radians. So let's get it into degrees. What does the 6 mean? 6 means 30. 5 30s, so therefore, we're talking about the tangent of 150 degrees. To find the tangent of 150 degrees, we first find reference angle, which is 30 degrees. We then find the tangent of 30 degrees, which is square root of 3 over 3. So, reference angle, chart, quadrant. What quadrant? 2. 150 degrees is in quadrant 2, which therefore means the tangent there is negative. So negative root 3 over 3. Bang. Questions there? Good? You'll have a bunch of these. There will be, there are skips. There are 2 skips in here. On the quiz tomorrow, there are 2 skips. There are more questions than normal because the questions are shorter, right? I mean, this isn't going to take you 5 seconds, but it's not going to take you 5 minutes either. Okay? So, I don't know how many questions there are, but it's not, you're going to have more than you usually do. Should be less than 100, I believe.
Okay. Perfect.
All right, secant of 240, go. Secant of 240 degrees. Is secant of 240 degrees a calculator problem? No. So you done for the season? Done for the day? Done for the week? That was before a game?
Yeah.
No, I mean, did you have a game yesterday?
No.
Oh, so it was just in practice that happened?
Yeah, it was on Friday.
Oh, it was on Friday?
Yeah.
I didn't know that. Why didn't you tell me? Then I heard somebody blew out a knee.
Yeah.
When did that happen?
Yesterday at practice. It was kind of funny because I went and I talked to the trainers and I got tested and everything. And I came back down, the trainers were driving the cart down there and went to talk to the girl that is in the dugout crying. And I was getting my stuff to leave.
All right, talk to me about secant of 240.
The reference angle is 60. Oh, it's 1 over the cosine.
Okay, so secant is the
Reciprocal
of cosine. So we're thinking about the cosine of 240 degrees. To get the cosine of 240 degrees, we
Reference angle.
find the reference angle, which is 60 degrees. So now we're talking about the
Cosine.
cosine of 60, which is 1/2.
And then reciprocal.
Reciprocal, to make it secant, gives us 2.
It's in quadrant.
Is that our answer?
No, it's negative.
Why not?
It's in quadrant.
Quadrant. 240 degrees in quadrant 3. Cosine is negative, so secant is negative, and there's our answer. Is the black problem any different? Why? Why is the black problem different? Because this is a calculator problem. How can you tell it's a calculator problem?
Decimal.
Because I have not seen that number on my chart ever. Right? I mean, that's, if we start seeing decimals basically, but certainly decimals that we don't know, now we're doing calculator problems. So go for
When you
it.
draw things, when you draw the nearest angle to x.
Alright, I put it here.
So when you draw or any angle, you can go immediately
Let's
to
go
x.
nearest degree.
So what's
I know for some of the problems tomorrow it'll be nearest degree. I will not use the phrase. We're not talking about that. Fair, in my testimony on it. How are we doing this problem? Okay, second. How do we know second?
Because we don't know the angle.
Yep. We're trying to find an angle. Every time we're trying to find an angle, it's going to be second. So second cosine of 0.7413.
42 degrees.
Theta is 42 degrees. 42 point what?
1.5.
0.15? Okay.
1.6.
So we're set?
No.
We're not set? We're set? We're not set? It's definitely one of the two, right? Either we are set or we're not set. In this case, we are not set. Why?
Cosine.
Because of this statement right there. What is that statement telling us?
There's two solutions.
All possible thetas in a revolution. How many revolutions? Just one, because we're only going up to 360. So basically, when we're going from 0 all the way around to 360, how many angles will give us a cosine of 0.7413? Definitely 1 or 2 or 4. 2? Why 2? Because there are 2 quadrants in which cosine is positive, and the other two quadrants, cosine is negative. And the ones that are negative obviously don't apply because we're looking for positive. What did we find here? We found the reference angle. This is the reference angle. We want to put it into quadrants 1 and 4, because in 1 and 4 is where cosine is positive. What is the angle in quadrant 1? 42 degrees. They're giving us the reference angle, they're also giving us the quadrant 1 angle. What do we have to do to get the quadrant 4 angle? Subtract from 360, which gives us 318 degrees. Okie dokie? Yes?
Yes.
Okay. Blue. Cosecant of theta equals negative 3.142. Theta is between 0 and 360. Go. Sure. Nearest degree, sounds good. All right, step one. Yeah, being that I don't have a cosecant button on my calculator, I don't want cosecant. Oops, that's blank. So I would prefer sine of theta is equal to 1 over negative 3.142. Right? What did we do in this step? We took the reciprocal of both sides, right? What's the reciprocal of cosecant? Sine. What's the reciprocal of negative 3.142? 1 over negative 3.142. So we took the reciprocal of both sides. Both sides. Yes. What's next?
Calculator.
Calculator. What are we typing into our calculator?
Not
Be
the
careful
negative.
here.
Second sine.
Second. Sine.
1 over
1 over
3.142.
negative.
No.
No. Karma says we shouldn't put the negative here. Is she right?
Yes.
We shouldn't put the negative here?
No.
Why not?
Because
Because
We'll break
that
it.
answers
She
it.
said sine.
Because if we put the negative in, what will it give us?
a negative answer.
Yeah, it'll give us something we don't want, to be honest with you. It'll give us something we don't want. Now, there are times when if we put the negative in, it would give us the right answer.
Like this
But
time.
especially when we're going 0 to 360, it might give us one correct answer, but it'll never give us both. So, what should we do instead? Don't put the negative in, because that way we will now get the reference angle. And reference angles we can work with. So, what do we get for our reference angle?
18.5.
So,
19.
it's 19, so it's 19.4 something?
No, 18.5.
Oh, I thought you said 19 point.
18.5.
Gotcha. Okay. So 19 degrees? All right. What do we need to do with that? Well, what should I be thinking about? Quadrants. What quadrants are we going to? Why? Because remember, we're talking about the negative. We didn't put the negative into the calculator, but the problem was the negative. So we need to deal with the negative, which means that we are going, because it's a sine, we're going to quadrants
3 and 4.
3 and 4. 19 degrees in quadrant 3. 199 degrees. How did we get it?
180 plus 19.
180 plus 99. If you're not sure whether to add or subtract or whatever, draw it. Draw the little coordinate plane and go, okay, I know that that's 180 and that's 360. And if I want quadrant 3, how am I going to get to quadrant 3? Well, it's bigger than 180, so we'll do 180 plus the reference angle, right? Okay. What about quadrant 4?
341.
360 minus the reference angle. 341 degrees. So 360, we're coming here. So we're going to go 360 minus the reference angle, right? Is this our answer?
Yes.
Yes, it is.
Teachers,
Exactly.
please pardon this
That's early.
interruption for bus change information.
Yes, sir.
City Ride Bus 329 is not coming today. Please take instead 305, 316, 328, or 330. Students, if you ride 331, it's not coming today either. So please take instead 320, 332, 335,
No buses are coming
337.
today. Walk home. Live in Maricopa. It's a long walk.
You'll get there
Stay
tomorrow.
hydrated.
You might have to give me an angular velocity problem. Actually, oh, where's my book? Books here. If we have a theta of 60 degrees, if something goes 60 degrees, and the time associated with that is 0.2 seconds, what is the angular velocity? By the way, what are you going to have to do with angular velocity? What units will our angular velocity be? Radians per whatever, right? But the point is that it's going to be radians, okay? So you can either do it before or after. I'd probably do it before just to make sure that I'm there. So theta is pi over 3? Yeah. So pi over 3 radians in 0.2 seconds. What do we do with the 0.2? We divide, is correct. It's angle divided by time, which makes sense because what are we trying to figure out here? We're trying to figure out what angle, so what will our units be in this problem? Radians per second, right? So we need to get that to be 1 second. So we'll divide by the number of seconds. So pi over 3 divided by 0.2, which of course, as everybody knows, is 5 pi over 3.
Yep.
How did you get that?
I just randomly guessed. How can I get that to be 1 second?
Multiply
Multiply by 5.
Multiply by what?
5.
Multiply by 5. So if we multiply that by 5 to get 1 second, then we'd have to multiply that by 5. And that's where the 5 pi over 3 comes from. 5 pi over 3 what? Radians per second. And I think that's what we'll be looking at tomorrow, that type of thing.
And then how do you translate that to linear velocity?
There was that little dinky formula. Remember that little
That
formula?
you do that times the radius? You do
Was omega equals, or no, v equals r omega. So we would just multiply that by the radius of the circle. And that'll give us our, because remember this is radians. So we're basically just converting radians to arc length. Sir? Oh, I mean, you'll pick the number and it'll be even. Understand? Understand? That was a concussed girl that came up with that. That was pretty good.
Yeah.
She's like, what does he say? I wasn't trying to be mean. I wasn't trying to be mean. Oh, wow, we got like a minute. Anything else? I will be pretty early tomorrow. I'll get in as early as I can, hopefully no later than 7:15. So the test is copied, and so I don't have to go running around or anything like that. Once I'm here. So if you get in early and want to ask questions, come on by. I will do as much as I can. All right?